Hey guys, we're on page 19 and we're talking about trig functions of any angle, so we're making it very general now. Before I do that though, let's go ahead and review really quickly what all of these functions are and how to find them. If I call this angle right here on the bottom left theta, and I call this my right angle, then we know that this side right here at the bottom, this leg is x. We know the right, on the right side, that's your y. And we know that this, which normally would be your hypotenuse, is r standing for radius. Now, to find one of the three sides, you know you can always use the Pythagorean theorem as long as you're given 2 out of 3 sides. Let's just go through, just like we did previously. If you were to find cos of your angle based on SOHCAHTOA, according to SOHCAHTOA, it would simply be adjacent over hypotenuse, which in this case is x over r. And so its secant, the reciprocal of cos, is going to be r over x. Sine, according to SOHCAHTOA, is opposite over hypotenuse. And in this case, it's going to be y over r. Cosecant, the reciprocal of sine, will be r over y. Tangent, according to SOHCAHTOA, is opposite over adjacent. In this case, y over x. Remember, it's always sine over cos. And its reciprocal cotangent will be x over y, or in other words, cos over sine. So that's stuff that you know. Now, if I keep that in mind and take a look at the first example on the next page, right over here, it says, determine the exact value of the 6 trig functions. So we have to find all 6 trig functions if you're given this simple point. Now what I want you to do is go ahead and graph that point just like you normally would. Where would 4, -7 be? So 4, -7 would be right over here in the 4th quadrant. What we're going to do is we're going to draw a triangle based on where that point is. So coming straight out of the origin, I'm going to form my triangle. And by the way, triangles are always formed connecting it back to the x-axis. Always back to the x-axis. So there's my triangle. Here's theta. There's your right angle. And I know the point is at 4, -7. So really what I'm already given is that my x value right over here is 4. My y value is -7. I do need to find the hypotenuse, and if you look for the hypotenuse, you'll see that it is square root of 65. Now all I have to do is take a look at that triangle and take a look at where the angle is itself and find all 6 trig functions. So I want to find sine of theta, its reciprocal cosecant of theta. I want cos of theta and its reciprocal secant of theta. I want tangent of theta and its reciprocal cotan of theta. So now if I go ahead and look for sine of theta, sine, remember, is only opposite over hypotenuse. So if I take a look at that, opposite is -7, hypotenuse is square root of 65, and of course you know we have to rationalize. And once you do, you get -7 square root of 65 over 65. So there's your sine value. Cosecant will be the reciprocal, and I'm going to take the reciprocal of the first of the original fraction to make it easier. So it'll be negative square root of 65 over 7. There's your cosecant. Cos of your angle will be adjacent over hypotenuse, so 4 over square root of 65. And of course we have to rationalize, so 4 square root of 65 over 65. There's your cos value. Secant will be its reciprocal, and again I'm going to take the reciprocal of the original fraction, so square root of 65 over 4, and there's your secant. Tangent is opposite over adjacent, so -7 over 4, and that's your value. I don't have to do anything there. Cotangent will be its reciprocal, so -4 over 7. There you go. So even though that point is not on the unit circle, even though those numbers are not on the unit circle, you can always still find all 6 trig functions, no matter what the angle is, no matter what the point is. Okay, now what I want you to do is, and we've seen these before, but we're going to take a look at these conditions. Now, if tangent, for number 1, it says, where is tangent a positive number? So tangent is positive in the first quadrant and in the third quadrant, because in the first and in the third, both sine and cosine have the same sign. In the first quadrant, they're both positive. In the second, they're both negative, and so if you were to find tangent, remember it's sine over cos, if you were to divide those, you end up getting a positive number. So tangent is positive only in quadrants 1 and 3. Okay, number 2, where is sine negative and tangent positive? So sine will be negative. Sine, remember, is your y value. It's going to be negative everywhere below the x-axis. So in quadrants 3 and 4. And tangent is positive, we just said, in quadrants 1 and 3. Because we have 4 different answers right here, what we really want is not them separately, but where do they both overlap? And if you take a look at the quadrants we just listed out, they do overlap in quadrant 3, and that's my answer. Number 3, it says, where is cos less than 0? Where is x a negative number? So x is negative on the entire left side of the unit circle. And so that refers to quadrants 2 and 3. And there's your answer. Number 4, it says, where is sine negative and cos also negative? Now that should be an easy one. Where are they both negative? In quadrant 3. I'm going to come back to number 5, but number 6, it says, where is sine positive and cos negative? So sine I know is positive in everywhere above the x-axis. So in quadrants 1 and quadrant 2. And I know cos is negative on the entire left side. So quadrants 2 and 3. Now where do they overlap? In quadrant 2. So your answer would be quadrant 2. Now going back to number 5, notice that it's saying where is sine equal to negative cosine? Now what I want you to do is break that down, because you know that sine refers to your y value, and you know cos refers to your x value. So now looking at it that way, it makes it a lot easier. Where is negative x and positive y? In which quadrant do you have negative x and positive y? Yep, in the second quadrant. So we're going to say in the second quadrant is where you'll find that. And actually, more specifically, where do you find that sine and cosine are the same? Where do you find, for which angle do you find that sine and cosine are both the same value? Right. So for the pi over 4 family, remember that's the only family that has the same fraction there twice for the coordinates. So for pi over 4, you have square root of 2 over 2, comma square root of 2 over 2. Now that we're looking at the second quadrant though, I know the pi over 4 family member there is 3 pi over 4, where x is negative, y is positive. And so I would say even more specifically, if it did ask me, I would say that theta is 3 pi over 4. Okay, now let's look at those a little bit more in detail. What if I give you now a value, which notice this is not on the unit circle, but again, I can go ahead and find all 6 trig functions by creating a triangle. What I'm going to do is, first of all, notice a couple of things. Cos is a positive value, and I know cos is positive in quadrants 1 and 4. But then it tells you that your angle, theta, is in the 4th quadrant. So what I know is that when I draw my triangle, it has to be in the 4th quadrant because it told me that. So here's my 4th quadrant. Again, you always draw your triangle toward the x-axis. So there's that. Here's my angle. And because I've been given cos, remember cos is adjacent over hypotenuse, so I know adjacent will be 3, and I know hypotenuse will be 5. And if you take a look at that, we do need to find the y value, we do need to find the opposite, and if you notice, this is a 3, 4, 5 triangle. Hopefully you remember that. The one thing that we really have to be careful is that because we're in the 4th quadrant, we have to infer some things. Because if you know anything about the 4th quadrant, you know that the x is positive, but the y is negative. So we have to actually put that in, even though it's not given to us. So now we have everything we need to find all 6 trig functions. So sine of theta, cosecant, its reciprocal, cos of theta, secant, its reciprocal, and tangent and cotangent, its reciprocal. So sine will be opposite over hypotenuse, so negative 4 over 5. Cosecant will be the reciprocal of that, negative 5 over 4. Cosine will be adjacent over hypotenuse, so 3 over 5. Secant will be its reciprocal, so 5 over 3. Tangent will be opposite over adjacent, so negative 4 over 3. And cotangent will be its reciprocal, negative 3 over 4. Number 8 gives you cosecant. Now remember, cosecant is a reciprocal of sine. So when I'm looking for all 6 trig functions, I'm actually already given cosecant. Let me go ahead and put that down. And I can tell then that its reciprocal, which is sine, will be negative 1/2. So there's 2 out of 6 trig functions already done. So I still have to find all 4 of these. So now I have to take a look, I have to draw a triangle, but I do have to take a look at where exactly this angle lies. And you may be able to take some guesses because of course that is on the unit circle. And so I know that sine is a negative number in the 3rd and 4th quadrants. But then it also gives me additional information. It says that not only is this true, you also have cos of an angle is less than 0. And cos is less than 0. It's negative in quadrants 2 and 3. So based on the overlap, I do have to create this triangle in the 3rd quadrant. So here's my 3rd quadrant. And I know that based on this value, that sine is negative 1/2. And so because we're in the 3rd quadrant, and because this is on the unit circle, your x value must be negative square root of 3 over 2. And by the way, that is an angle. See if you can figure out which angle that is. But I'm going to move on. So cos, then, according to that, is negative root 3 over 2. That's my x value. The secant, after you rationalize, will get you negative 2 root 3 over 3. Tangent will be sine over cos, so negative 1/2 over negative root 3 over 2, which we'll find, which you will get to be square root of 3 over 3 after you rationalize and after you simplify. Then cotangent will simply be square root of 3. Okay, now taking a look at the next section. If I ask you to evaluate sine, cosine, and tangent without a calculator, using angles that you may or may not know, there are some ways that you can kind of work around drawing pictures and making it too complicated. So if I take a look at number 9, you can actually find, because 300 degrees is exactly 11 pi over 6, and that does have a coordinate, and so I'm going to let you do that one. But number 10, if I take a look at it, you can actually, if you wanted, you could draw a picture and go through several revolutions to figure out where negative 840 would be, or you can use what you know to figure out an angle in the positive direction where negative 840 would be. What I'm trying to say is try to find a coterminal angle of the angle given. So let me try to find that. Let's add 360 and see what happens, because remember, coterminal angles, you just keep adding revolutions until you find something that you know. So if I add 360, if I add 1 revolution, I end up with negative 480. And that too, I may not know so well, so let me add another revolution. And I'm just going to keep adding revolutions until I find something that I can work with. That's going to give me negative 120. And I know where negative 120 will be, going in the negative direction, but let me see if I can find something even better. So I'm going to add another 360. And if I do that, I'll find 240 degrees. Now that's a good number. 240 degrees I know is right over here. So what that tells me is that negative 840 and positive 240 degrees are coterminal angles. But even more so, that's not really what I wanted. I want to find all of the trig functions that are listed here, sine, cosine, and tangent. And at 240 degrees, if you remember your coordinates, it's negative 1/2, comma, negative square root of 3 over 2. So sine at negative 840 degrees is your y value, which is negative root 3 over 2. Cos at negative 840 degrees is your x value, which is negative 1/2. And tangent at negative 840 is sine over cos, which gives you square root of 3 after you've simplified and after you've rationalized. Number 11, you can actually work the same way. So again, this is, if you take a look at it, it is past 1 revolution, so you can either draw it out and figure out where it would be, or you can use coterminal angles. So if I add, in this case, because it's in radian form, I wouldn't add 360 degrees, but I could add 2 pi. Now that's just going to get me further and further away. Because this is a positive angle and it's past 1 positive revolution, I'm going to take away a revolution. So I'm going to subtract from it 2 pi. Now, to be able to work with that, I do have to work with fractions. So put it over 1, multiply by 3 to get a common denominator, so that's 10 pi over 3 minus 6 pi over 3, giving me 4 pi over 3. And I know 4 pi over 3 is on the unit circle, and it's right over here. And so again, I know sine at 10 pi over 3 is negative root 3 over 2. I know cos at 10 pi over 3 is negative 1/2. And I know tangent at 10 pi over 3 is square root of 3. There you go. Okay, and the very last part for numbers 12, 13, and 14, it's going to really make you think backwards, because now if you take a look at number 12, I've given you the value and I'm asking for the angle. So for number 12, this is how you would read it. This is how you can read it. For what angle is your sine value root 3 over 2? And remember, sine is your y value, so and it is positive. So we have to say that, well, sine is positive in quadrants 1 and 2. And we know because on the triangles, the longer sides are square root of 3 over 2, then that tells me, if I think about it a little bit, I know that my 60-degree angles are what that's referring to. So really, I have two answers because there's no other restrictions at all. It tells me up here that I can have my answers anywhere between 0 and pi, so that lets me stay open to both of these quadrants. I do have to write my answer in radians, so I'm going to say 60 degrees, which is actually pi over 3, and this right here would be double that, so 2 pi over 3. So my answers are pi over 3 and 2 pi over 3. Number 13, it says, or the way you can read it is, for what angle is your cos value 1? And if you take a look at your unit circle, the only place where you even have a 1 is with the number 0. Well, where is your x value a positive 1? That's the only place right there, at 0 radians or at 360 radians. 360 degrees, or 2 pi. Now, can I use 2 pi as an answer? No, I can't, because I'm restricted only to give answers up till pi. So my only answer for that is 0 radians. Number 14, it's asking you for what angle is tangent undefined. Now we've talked about this a little bit. You only have undefined answers when you have a 0 at the bottom. And with a 0, the only thing that's on the unit circle is a 1. So where do you have, and because we're talking about tangent, we know tangent is sine over cos. So for what angle is sine 1 and cos 0? If you translate that into a point, that would come out to be 0, 1. Where is that point? It's at 90 degrees, so right up here. And of course we have to write it in radians, so pi over 2. And that's it. Okay, we'll talk about more of this tomorrow. That's it for now.